school, and then and said if that intruder would ever to come, he would beat him up with a hammer. And then
He subbed for our class one time.
and then he was like, he like would like take pills in class and be like, look at my whole drawer, and he'd like pull out a drawer and like full of pills.
When I did the equations, did I have to actually solve the equation?
Yeah, he also taught us longitudinal longitudinal.
Honors Geometry Wednesday, my dudes. On Wednesdays we wear pink, and this is pink. Goodness gracious. SWPA students will be able to use parallel lines and transversals to find angle measures. Section 4.2, okay? We're going to start using parallel lines and transversals to find angle measures.
Hey,
here.
Mr. Ross,
What's up?
No.
What homework?
Or you did have homework.
Those two equations we had to solve? Yep, we're going to go over that. So we're going to do this table, and then we went over this corresponding angle postulate, okay?
What are we supposed to fill out? The corresponding angle postulate?
Okay. Alright. So we did the first example together already. Okay. Second example. Amber, what kind of angles were these? Very good. Same side, what? Same side interior angles. Okay, they're on the same side of the transversal, and they're both interior to these two lines cut by the transversal. Now, does this mean, since these two lines are parallel, are they supplementary or congruent? Sarah?
Supplementary.
Supplementary. Jocelyn, give me the equation we use.
6b minus 9 plus 12
Very good. That does equal 180. Combine like terms. 12b, 6b and 12b get 18b. Negative 9 plus 11 get 2. We end up getting 18b is equal to 18b. Yep, is equal to 170. I already wrote 170 there.
That's
Where did you get 180? Oh.
Whoa.
That's not
did that right.
That's
Mr.
not
Ross,
right.
I'm not following.
Okay.
I don't know because if you add negative 9 and 11 together, it's not 12. 178.
It's 2. It's a plus 2.
It's 9.8. Okay. That makes much more sense. I'm sorry.
I forgive you. Sorry, Mr. Possible.
Yeah, I'm not feeling too
Not feeling too good. Mr. Possible. On our third option, our third one here, okay? Rachel, what kind of angles were these? I think that's why I asked it. I know you did this homework, so.
I messed up.
consecutive.
Nope, I do this one. Same side interior angles. Okay, they are interior angles, but they're on the same side. Maggie, what are they?
They are alternate interior.
Very good. Alternate interior angles. They alternate those sides of the transversals. Okay? One's on the top, one's on the bottom of the transversal, but they are both interior. So this means when these two lines are parallel, are they congruent or supplementary? Congruent. Okay? What's our equations for this one, Evan?
6c minus 9 equals 2c plus 11.
Couldn't agree more, okay? We're going to move our c's to the left, 4c, move our constants to the right, equals 20. Divide by 4, and c equals what number? 5. Very good. Now, if I asked you guys, could we go back and find the measure of these angles? Yeah, and could we plug it into both of these? And what should happen if we plug it into both? They should equal the same. What happens if they don't equal the same?
You've done messed
Something
up.
wrong, okay? On this one, if we plug it into both angles, should they be the same?
Yes.
No. What should they add up to? 180. Okay.
Somebody drop
Continuing on. Okay. What is the measure of angle 6? Okay. So don't blurt. Okay. Don't blurt. I want you guys to figure out what the measure of angle 6 is. And there's a couple ways you can do this. I'm thinking of two primary ways you can do this. Actually, there's just a lot of ways you can do it.
But yeah, there's always like 10 ways because why not?
Yes.
Because you can figure out it with
That's
non-equal
fun.
figure that you have no idea what it is.
Not yet.
Yeah, I say the answer?
Not yet.
I definitely feel like I got it wrong.
No, I definitely got it probably wrong. Wait, hold on.
Look!
Actually, hold on. I did do it right.
Actually, hold on.
Wait.
Oh, maybe that.
How did you
This
make
next one
friends
looks like
in
a lot
school?
of hard work and I don't really want to do it.
How did you find people that weren't just like repulsed by your humor?
Yeah, right? Like, I don't have a girlfriend. Right?
I said how.
Yeah.
It's not possible.
No. Like, I don't like out, right?
Why, hello.
I did, because you were going to say no. It's just that corner. There's so
Rowan,
much-
did you shower last week? That's all I asked. Did she smell that bad?
No, I love her. It's like, it's the corner. I just can't do it.
It's too warm for you.
Yeah.
It's too close to 90 degrees.
Oh my goodness, my
You handed it to me, right?
That's it. That's it.
Okay.
Carly, what would the measure of angle 6 be?
55.
How do you figure that out?
This worse?
The same as measure 3.
Okay, why?
Because they're interior, alternate interior.
Okay, because they're alternate interior angles. Okay, angles 3 and angle 6
Wait,
are alternate interior angles.
I did it wrong.
so would that mean that number like 5 is 125?
Number 5 would be 125. How would you know that?
That's
Because
what I
you
did.
have to add them up.
Because they're a linear pair. Green, how did you find angle 6?
I did it a really wrong way.
Okay, show me.
The vertical angles of angle 2 and angle 3.
Okay, so you said angle 2 and angle 3 are vertical angles, so they're congruent. Continue.
Angle 2 and angle 5 are corresponding angles, so they're congruent.
Angle 2 and 5, no.
No. Then I did a 180 minus 55 and found no.
But 2 and 5 are not
No, for
corresponding.
1 and 2.
Oh, what you said? Oh, 1 and 2 was a linear pair.
Yeah.
And he said 1 and 5 were corresponding.
Yeah.
And then he said, hey, these are a linear pair.
Yeah.
Okay. Did you do it that way on purpose?
Yeah.
Is that the only way like you knew how, or you're like, I'm just gonna have to follow
I
this?
just did it.
Is that what came naturally?
Yeah.
Interesting. But it worked, didn't it?
It worked.
Okay. So there's lots of ways you can do this. Peyton.
Yeah, I'm confused. Are we on? Oh my goodness.
Nice to meet you.
This is gonna be a very long class.
Not my
Okay,
fault.
no wait,
I'm listening.
it's so confusing.
Okay.
Okay,
These problems are still listening to you.
are we on this one?
We're on example 2. It's the first example.
I'm going
No,
confused.
next page.
That
First
sucks.
I did
example.
not even
That sucks.
My voice has been cracking like
No,
no.
no, like you shaved your beard. It's that first example.
Oh, okay. My bad. Moving on. I
I did
apologize.
it.
Okay,
Sorry.
continuing on. Are there a lot of Alyssa?
Oh, I was just gonna say I didn't use any. I didn't use the.
Okay. What'd you use?
I used the vertical angles.
Okay, so you did 5 and 2 are vertical angles. And then what'd you do?
2 and 6
And then it said that 2 and 6 are corresponding. Okay? So Alyssa said, hey, 55 and this angle 2 are vertical angles, and then 2 and 6 are corresponding angles, so they're congruent. Now, this is only true because these lines are parallel. If these lines were not parallel, this would not be true. Okay? Questions on that? Okay, continuing on.
How'd you get 125?
Because these form a linear pair, so you have to add up to 180.
Okay, so you subtract 55.
Yes.
Okay.
I could get this.
I like this.
It's just about identifying a relationship and memorizing such a fact.
The way they label the angles every time.
They love it. This one makes sense though. 1, 2, 3, 4, 5, 6, 7, 8.
I didn't say it didn't make sense, but why change? Just keep
Kevin,
it
let
the
me see your
same.
finger again.
Look at what I write on here.
The other one.
This is reason enough. Okay. Given that L is parallel to M, given that L is parallel to M, line L is parallel to line M, answer the following. Shush. Answer these following questions and give the angle relationship we used. So, they are separate questions. Does that mean you use question A to help you with question E? No! Question A. If measure of angle 7 is equal to 100 degrees, write this in pencil, not pen, Find the measure of angle 3.
100.
Okay, how do you know that?
Because it's opposite sides.
Because 3 and 7 are congruent.
Yeah, 3 and 7 are congruent because what kind of angles are they?
Alternate interior angles.
They're alternate interior angles, okay? So we're told to find the measure of the relationship. We were asked to find the measure. So the measure of angle 3 is equal to 100 degrees. And why the angle ratio we use is alternate interior angles. And I'm okay with you guys shortening it to alternate angles, but we say it as alternate interior angles. I know, okay?
You're wrong.
Now if we look on letter B, if measure of angle 7 is 95 degrees, measure of angle 7 changed, okay? They change, okay? And that's okay. These are separate problems, okay? So now let's say measure of angle 7 is 95 degrees. Can we find the measure of angle 6? How'd you get 85? Because they're what kind of angles, Kevin?
Same side interior.
They're same side interior angles. The measure of angle 6 is 85 degrees.
That would be
Because they are same side interior angles.
I don't get it.
So they're supplementary.
Hold up.
I don't get it.
I was about to do that on the long way too.
So 95 plus 85.
Okay, so then now 3 is 95?
Wait, but how do you know that 7
Yes,
and 6 are the
Okay? Because they're on the same side of the transversal. They're both on, this is the transversal T. They're both on the right side, so they're the same
So
side.
if they're on the same side, then they're different angles. But if they're
You know,
on
if they're on the
sides-
same side, then it's probably gonna be same side. If they're on the same side in interior, they're same side interior angles.
Okay, but if they're on the outside, are they the same angles?
They could be same side exterior, and those are gonna be supplementary as well. But let's say 8 and 6, those are on the same side, and they're corresponding.
So if they're
Corresponding is where we went like Taylor, corresponding is where we went like this.
yeah.
Is
Well, I
in the
know
back.
that, but like I just don't understand
So I
why.
would say the same.
Alright, I got the next one.
The names be complicated stuff.
Like I don't know. I don't know.
I think it's gonna take practice of identifying these relationships we're seeing and practicing. Hey, these are this kind, okay? And try to memorize the names, okay? I want you guys to do C through F. I want you guys to do C, D, E, and F. Okay? And once again, yes, each scenario changes. Once we start on letter C, we forget what happened at A and B. Once we start on C, we just kind of forget what happened in A and B with measurements. Okay? Once you have C, D, E, and F done, I want you to raise your hand. Or if you have a question, I want you to raise your hand. Once you have C, D, E, and F done, or a question, I want you to raise your hand. C through F. Make sure we're listing the relationship, right? So let's see what this relationship is. So how about just try 1, 5. Those are also such angles. So you get a straight there. You also could do the corresponding too. That makes sense? You don't want me to check? No. I guess so. So again, angles are opposite each other. If they want to be straight. Good luck, Rachel. Did you go 7 to 1 in the 1 league? Jake, there's a 7 8 grade. That's the way you're paired. corresponding. And the vertical should be congruent, right? So corresponding exterior and vertical congruent. You got something like. So you can get there that way. I think it'd be a different measure. Does that make sense?
Oh, yeah.
But you can also go straight there by alternate exteriors.
I don't know. We do it at the one that we were. I don't know which one that we
Say that again? No. When's?
Spit like into my hair when as you cough it up, and I'm very sore on my stomach. So every time I cough, it's like ow, 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 ow.
Look at two of these.
We have like the hair deals in life.
Compared to the transversal, right? Compared to the transversal, okay. So two of these. So they're all each other. Okay. Marks. Okay. There you go. So let's actually go back to chapter 1, 2, 3, 4. So just do the relation. So that's the format. They're still using this one. So 7 and 8. You've seen that one before. That's another format. When you're done or have questions, make sure you're raising your hand. When you're done or have questions, make sure you're raising your hand.
I know it.
That'd be what we call. As long as you continue to explain yourself now. Oh, okay. Okay, so let's look at C, okay? So there's lots of different ways you can get to all of these. Let's try and do our shortest way on these, okay? So measure angle 1 and measure angle 5, what kind of angles are those? Simone? Yeah, they're alternate exterior angles. The alternate sides of the transversal, they're both exterior of those two lines. And alternate exterior angles are congruent or supplementary. Which one? Congruent, okay? So this one's also 120 degrees. So the measure of angle 5 is equal to 120 degrees. Okay? On letter D, measuring angle 2 is equal to 40. By measuring angle 8, 2 and 8, what kind of angles are those? Vertical angles. That's a throwback to previous chapters, okay? Measuring angle 8 is equal to what then? 40 degrees. Vertical angles are congruent regardless of whether those lines are parallel. Vertical angles are congruent. Okay? On letter E, excuse me, not number E, letter E. Angle 4 and angle 2, what kind of angles are angle 4 and angle 2? Corresponding angles. We can shorten that one down to CORR. Corresponding angles. They're kind of in the same position. And corresponding angles when those lines are parallel are what?
The same thing.
Congruent. So this one's also 40 degrees. Okay? Letter F, angle 7 and angle 8, what kind of angles are those? Right next to each other, they form a straight line. Linear pair. Okay? So what would the measure of angle 8 be then? 55 degrees there, supplementary. Okay?
Wait, was the linear pair thing
Okay, G and H. These have asterisks next to them, don't they? Okay, there's a reason for that. Because these, you have to go 2 steps to get there. If you look at angle 5 and angle 2, there is no relation that gets you right there. So you have to go through another angle first to get there. So you have to go through another angle first to get there, okay? So if we start out with angle 5 being 165, what angle could we go to get to 2?
Vertical.
Okay, we can use vertical angles to get to 3. Okay, so we can say, hey, it's vertical angles. So the measure of angle 3 is equal to 165. Now could we get to measure of angle 3? Not corresponding with 2, but what is it with 2?
Same side.
Same side interior. Hold on. But they are supplementary like a linear pair. So the measure of angle 2 is equal to 15 degrees. Very good. Okay. We have to do we have to go through a third angle. We have to do 2 steps on that one. And there's no way to get straight from 5 to 2. You have to do 2 steps. There's no angle relationship there. Okay. The same thing is true for H. 3 and 8, angles 3 and 8. There's no angle relationship there. So there's a few different ways you can do it. There's a few different ways you can do this though. Okay. Does somebody have a suggestion on how we go from 3 to 8? Okay, Sarah. Okay, Graydon.
A linear pair between
3 and 6 do form a linear pair, so they add up to what?
3 and 6.
180. So angle 6 is 40 degrees. So we say, okay, measure of angle 6 is 40 degrees. And we know that because they're a linear pair. So we write that down. So we say, hey, that's how we know. So now how can we go from angle 6 to angle 8? They're corresponding angles, so they're congruent. They're both in the top right of the vertex. So the measure of angle 8 is equal to 40 degrees as well. And our reasoning for that is that they're corresponding angles. There.
Can you also do a linear pair between 3 and 4?
Yep.
And then,
And then you can alternate exterior angles. Yeah, sure.
okay.
You can do a vertical angles with 3 and 5. And then you can go same side exterior. You can do corresponding with 3 and 1, and then a linear pair. You can do same side interior with 3 and 2. And then do vertical angles. You can do alternate interior with 7, and then do linear pair. You could really go to literally any angle.
Oh, okay.
We could
Yeah.
fill out a
Literally.
whole chart with one.
You literally could go to any other angle there.
Literally.
Literally, you could go to any other
Well,
angle.
that alright.
Okay. You just have to explain what you did.
Okay.
But you could go to any angle
Ow.
and get it.
Yeah, that was
I
great.
Questions on that?
I think it's pretty cool. Probably every angle.
Right?
Than one angle.
You just need one angle and the fact that 2 lines are parallel. Okay, continuing on. Okay, so here we see some shapes, right? We see some shapes. Okay, we see a trapezoid. Okay, I know it's a trapezoid. It's a trapezoid. We'll learn more about that next semester. Okay. Find the measure of each angle. Okay, always blank lines when given shapes. Right now we see 2 parallel lines. We don't really see much. Okay, it says always extend. Always extend lines when you're given shapes. Okay. So here, we're going to take these lines and we're going to continue them on. We're going to continue them on. I'm going to take these lines and I'm just going to continue on. I'm just going to extend them in the same direction they're already going. I'm changing the direction. I'm extending them in the same direction they're already going. Because now, if we begin to look at this, we can see, hey, do A and D have an angle relationship? Because these are parallel lines cut by a transversal. What kind of angles would A and D be? Same side, interior. They're on the same side of this transversal. They're interior of these 2 parallel lines. So there's-
Gauss's equation should have 180, and we can solve that.
Yep. So it's the same side interior angles, meaning they're supplementary, which Graydon said they add up to 180. So we can solve that. Who can give me my equation that we would use? Okay, Peyton, go ahead.
So for A and B,
Mhm.
would you do x minus 12 plus 2x plus 3y
Nope,
or
nope.
plus y plus 8?
Nope, we're not worried about these 2 angles.
So then equals
If these two add up to 180, we're gonna add them to 180. And solve. Rachel. Nope, if you want to, you can though. Because either way, you're gonna solve it the same way. Because you can't do anything inside the parentheses. And it's just adding. You don't have to worry about distributing. X plus 2x is what? 3x minus 12 equals 180. 3x will equal what? 182? Because you add 12 on both sides. Divided by 3. And x is equal to 64.
Oh my goodness. You just had that on top of your head.
No idea what that is. No, well, okay, so 192 is kind of close to 180, right? And 3 goes into 18 6 times.
Oh.
So 3 goes into 180 16 times. And so I need 12 more than that. So that'd be 4 more 3s. 3 times 4. So I did 16 plus 4.
Why are you laughing?
Yeah, that's it. It's a trick. It's a mental math trick. It's to manipulate numbers and just find numbers that are close to it, and then get the rest of the way there. Because if you can get most of the way there, if you can figure out, oh, it's 60 something, well, then you can figure out from there pretty like a lot. So that's just a mental math trick I do. I like that a lot. What's up?
Please tell me we're not doing the next step.
Oh, okay. We're gonna do the next stuff though. Okay. So next I have theorems and postulates. Okay. So hey, this is just what we've already learned.
This is already
Swear to God, if we do it.
grab my breakout and bring it in.
Perfect. Okay. So we've already learned this. Okay. We've already learned these. We're just attaching names to them.
Oh, I remember those.
I literally just retook a test over it, so I'm not very rethinking.
Voices off, please. Thank you. Okay. So so these are just our angle relationships. We already know these. We just haven't given them names. Alternate exterior angles theorem. It just says, hey, if two parallel lines are cut by a transversal, alternate angles are congruent. We already knew that. We already made that in our chart. We've already been using it. We're just saying, hey, here's our theorem for it. Yes.
Why have I seen that in like 6th grade? I remember all those from like
Oh, you went to St. John's.
Yeah, probably because you went to St.
Johnson. No idea what you're talking
you don't remember that? Okay, Jocelyn.
So we have all these different ones. Notice alternate exterior angles, alternate interior angles, corresponding angles. We've seen those.
Yeah.
And we know what it says is, hey, when you have two parallel lines cut by a transversal, these types of angles are congruent.
about. No, I don't know.
Vertical angles theorem, we've used that. It says vertical angles are always congruent. Same side exterior angles and same side interior angles. We said just earlier, hey, when those two lines are parallel, these are going to be supplementary as well. We wrote that in the facts column of our table, okay? And linear pair are always supplementary, okay? So if we could put a little star here and say, hey, these two stars, okay? Star means that they're always true. But when are the other 5 true?
When
Only when the two lines are parallel, okay? Alyssa.
Oh, are we gonna have to remember which ones are postulates and which ones are
I'm not gonna be too strict on that. I don't know how important that is for you guys to know. I don't really think it's terribly important for you guys to remember the postulate versus the theorem, okay? The reason why, okay, that there are postulates and theorems, okay? Corresponding angles postulate, that was the first one we were given of the new 5. Okay? That was the first one we were given. Okay? And if we recall, we probably don't. But if you recall, postulates are things that we just have to assume are true. So that was assumed to be true. And then from that, we went and found the other 4, didn't we? You guys remember going through that picture the last class? Okay, I'll pull it back up here.
Yeah, remember.
Okay? We went through this picture and said, hey, we have the corresponding angles postulate. And said, hey, if we have these two parallel lines, corresponding angles are congruent. And we said, okay, if we know that in one angle measure, we're able to find all these other angle measures. And from that, we said, oh, well then alternate exterior angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary, same side exterior angles are supplementary. So those were all theorems that were proven based upon the one postulate. So you had to start somewhere. So we started with the postulate, like historically, it started with that postulate, and then all these theorems were built upon that. So that's why there's theorems versus postulates. But I'm not going to be insanely strict and count off points if you say theorem when it's a postulate, or if you say postulate when it's a theorem. Okay. You might have done a section on that. You might have taken the right class there. You might have done the geometry section.
last year's algebra? I took that.
Yeah, I do that. Yeah. Yeah.
I don't know why I redid it, that was kind of stupid.
It's a common thing a lot of St. John students doing. Hey, now we're gonna put these into practice. Okay, we're gonna prove some angle relationships here, okay?
But what if we didn't, I think it's the worst thing.
No.
Proofs
You know,
don't go away.
we just skip over this. You never happen.
Okay, proofs don't go away. Okay? So, guys, we're actually almost clear here. Okay? So, we're given A is parallel to B. Here's what I like to do. I like to mark that. It's already marked though with these arrows. That's convenient. So it's gonna be my first statement. A is parallel to B. Thank you, Rowan. And that's given. Our reasons are given to us this time. And the first reason given, our first statement is always a given. Now we're trying to end up proving that 1 is congruent to 7. Okay?
So you can put that for 4.
You can put that for 4.
Boom, I only got 2.
We're halfway there. Okay.
Oh.
So, corresponding angles postulate. So what kind of angles would we be dealing with if we're talking about a corresponding angles postulate? 1 and 5. Because 1 and 5 are the only corresponding angles that we see that are labeled even.
Hand raised.
Okay? So we know, what would we know about 1 and 5 from the corresponding angles postulate? They're congruent. We don't know any measures, but we know they're congruent. Okay? Vertical angles theorem. Well, if we're at angle 5 and we know those were congruent, what would 5 go to? 7 by the vertical angles theorem. So angle 5 is congruent to angle 7. Okay? So now we can go from 5 to 7 because if we even look at our picture that we labeled it, is it decently obvious to us that hey, 1 and 7 have to be congruent now?
Yes.
Yeah, okay. So we can use the transitive property to go straight between the middleman 5 and go straight from 1 to 7. Okay? Now hey, here's the thing. We could also say, couldn't we have just gone straight from angle 1 to angle 7? How would we have? Alternate exterior angles theorem, okay? So what this proof actually is this is actually proving the alternate exterior angles theorem. This is a 4-step proof that actually proves that the alternate exterior angles theorem is a thing.
Wow.
So this is how you actually prove that that theorem is even in existence. So we actually just proved a theorem exists. Isn't that pretty cool? Just saying. Okay, about 5 hours.
I did math one day for
Just a
7
little bit.
hours.
Wait, what?
Okay. If you can wait 5-10 minutes, I'll go.
Guys, I got the first one.
Okay. Okay. Yes, this next one, okay? Green's got the first one he said. Once again, this is another one where we could do it in 2 steps, but this is actually proving a theorem. We could do it in 2 steps, but this is actually proving another one of our theorems. Okay? So Graydon, you seem pretty proud that you got our first reason. What is our first reason?
It's given.
Good work, yes. I'm impressed.
I
I
wish
did
we
not
could-
expect you to get that.
Given and at the end.
Okay? So we're saying that P is parallel to Q. I like to label my information. So I'm going to label that they're parallel with those arrows. Then we say, hey, angle 3 is congruent to angle 2, so I go mark those. They're congruent. What kind of angles are those?
Vertical angle.
Vertical angles. So what's going to be our reason?
Vertical angles theorem.
Yeah, so if we can remember what type of angles these are, we can remember our theorems, because this just comes from the name. Vertical angles theorem.
I got the next one.
I do too.
Okay?
Can I have the last one?
Go ahead, Peyton.
Okay, so 1 is congruent to 3.
Yep.
So then would that be corresponding angles?
That would be our corresponding angles, and that would be our
Well-
corresponding angles postulate. Very good. Postulate, kind of like post Malone. Okay. Okay. Yeah, and hey, since 3 only had 1 arc, 1 is congruent to that, so we make it with 1 arc. Now, on our picture, it might seem fairly obvious to us that 1 and 2 are congruent, which is hey, what we're trying to prove. And how could we get there without using the angle relationship, but only using what we have in 2 and 3? Not transitive property substitution. Okay, I said not using that relationship. because we're trying to prove this relationship. Because what angle relationship does this prove exists?
Alternate interior.
Yeah, this proves that alternate interior angles are congruent. Okay? So once again, we just proved that the theorem was true. We proved that alternate interior angles are in fact congruent. Okay, Peyton.
So is this like, oh, I saw a voice.
Yeah, that's okay. Some of us go through puberty times. Some of us go through puberty twice.
So is this what we were doing before, but like, are all of like the transitive substitutional properties in that too? Okay. So we're just adding it.
Yeah.
Yeah.
This next thing is the worst thing I've ever seen in my entire life.
I hate that.
Before? Okay. Okay. Any other questions on example 6? Let's go to the last part here.
No,
Too bad.
that is awful.
What's your question?
There's so many things wrong
Why are
with
we
that.
doing this?
Because I was making you guys cry.
Because it helps with
Oh, good. I'm relieved. I might actually be able to do my job now. I was thinking I was a little bit low on my quota, so. Okay.
What was that?
If there are two sets of parallel lines, okay, so if we look here at this picture, we have two sets of parallel lines. L is parallel to M, P is parallel to Q. Is P parallel to M though?
No.
No, one has one arrow, one has two arrows, and they obviously intersect, okay? So there's two sets of parallel lines right now. There's this set of parallel lines
Yeah, I think.
with L and M, and there's this set of parallel lines running left and right, P and Q. And so if there are two sets of parallel lines, each acts as a transversal. Okay? Each acts as a transversal.
You did not give me
Wait,
enough
so there's
space.
like
Each line
four
or each
transversals here?
congruent?
I wrote it on there. What do you say?
Is it each line acts as transversal? or
Each line can act as a transversal. Let's think about it this way.
Right.
Okay? We're given 105 degrees for this angle, and we're given that we have two sets of parallel lines. Okay? Now, a helpful way for us to kind of think about this, to kind of digest what's happening, and figure out what's happening here, okay, is if I cover this up, is this a lot easier to see what's going on here? Okay? It is. Or if I do this, guys, if I cover this up, is it a lot easier to see what's going on over on the right side?
Yes.
Yeah, okay, so what we're saying is right here we have two parallel lines cut by a transversal. We have all these angle relationships. Okay? Down below we have these two parallel lines cut by a transversal. We have all these angle relationships going on, okay? And then once we get to the rest, we can even get up here by covering up like this line, and you have these two parallel lines cut by a transversal. Or we cover this line, we have these two parallel lines cut by a transversal. So we have all sorts of different ways we can address this. It's fun, okay? This is kind of like a puzzle. Okay. So from here, from knowing measuring a 1 of 5, or this is 105 degrees, we can find all the other 8 angles. Right now, we can find the other 8 angles. These are angle relationships. Peyton, can you help me find one? We have a question.
Okay, so then, what is that number? So like, what's 1 of 5? Does it have a number?
That's an angle measure.
Okay.
That's
so then
this
what-
angle measure right here.
So would then that be congruent to 3?
Okay, how so?
Because they're both exterior.
Not exterior, they're interior. If I cover up this line, and so we see the two parallel lines cut by a transversal, they're what kind of interior angles? Alternate interior angles. And alternate interior angles are congruent. So if this is 105, this is 105. Okay? So that's one example of how we can find a measure. What's another measure we can find? Raise your hand if you can help me with another measure that we can find. Okay, Alyssa. Okay, what would that 7 be? Okay, and then there's two ways we could know that. What's one of them? Okay, using 3, what kind of angles are 3 and 7? Okay, they're on the same side, but they're not interior or exterior. So it might be a different name. Do they kind of look like they're in the same spot? Corresponding angles. Okay, so our corresponding angle postulate says, hey, if we have these two parallel lines cut by a transversal, they're congruent. Okay, what's the other way we can know angle 3 or angle 7? Vertical angles with this 105 that we're given. Those are congruent regardless of whether we have parallel lines. Okay, doesn't give another angle we can find? 5. Okay, how could we find 5? It's
vertical angle 3.
It's a vertical angle of 3, so it's congruent. Okay, that's regardless of if it's parallel. Are there another 2 ways we can find 5 right now?
Yeah.
How else could we find 5 right now? Corresponding with our given, and what is it with angle 7? Alternate exterior. Very good. Okay, so there's all sorts of different ways we can find these, okay? So now that we kind of found this whole right side, you can cover this up and you can do the whole top. Or you can cover this up, you can do the whole bottom. Or, yeah, so there's all sorts of things you can do now. Okay? So raise your hand if you have another angle we can find that you're seeing. Okay? Hayden.
2 is 1 5.
Okay? How do you say that?
Because 2 and 5 are both
Corresponding. 2 and 5 are corresponding. They're in the same spot. Okay? So they're congruent because those 2 lines are parallel. All of them are parallel. Okay? And it's another way. What's another way that we can know that 2 is 105? Say it louder, Sarah.
Alternative exterior.
Yeah, alternate exterior angles with 3. Very good. Okay? Rachel. Yep. Very good. 8 is a vertical angle of 2. Okay. Are there another? Bless you, let's rain down after forget. Bless you, let's rain down after forget. What's another way we can know angle 8? Corresponding with 3. What's another way we can know angle 8? Alternate interior with 5. So there's all sorts of different answers. Okay. These are all possible answers. I'm just kind of continuing trying to rework that. There's more than one way to do this. There's more than one way to skin a cat. Okay.
Yes.
So yes. Okay.
Jimmy,
It's a
you would know
terrible
that.
thing to say.
Okay.
Yes.
Okay. Go to the screen. Okay. So what's another angle we could find here? James, I can see this.
Oh, I don't know.
Okay. Kevin.
Angle 6.
Angle 6. How do we find angle 6?
Corresponding.
With what?
7.
Okay. It corresponds with 7. Okay. It's also alternate interior with 105. Hey, wait. If we cover up the right side, do we see that angle 6 can match up with any of these angles too? Yeah. It's corresponding with 8. It's alternate exterior with 2. Okay. So either way, it's congruent. So you can find it with the left side here, okay, or you can find it with down the bottom, these 4, okay? Taylor, what are you seeing?
4.
Okay, what's angle 4 going to be? 75, how do we get that?
Because it's on the same line. Or it's supplementary to 1 or 7, which is also 1 5. Or wait, this is just.
Not anything with angle 7. Doesn't have an angle relationship with angle 7, but it has an angle relationship with 8. They are same side what? It's same side interior, so they're supplementary, okay? What's another way you can know angle 4, guys? Alyssa? Okay.
So, can you use corresponding angles like that?
Nope. Nope. Are you saying like 7 to like 8? No, that's a great question. We can't use 7, 8, because if we look at any 2 parallel lines, okay, there's no relationship between 7 and 8. Because if we say, okay, we're talking about these 2 parallel lines, okay, cut by this transversal, well, that only includes 7, not 8. Okay? Or if we talk about these 2 parallel lines again, but cut by this transversal, that includes 8, but not 7. Or if you say, okay, let's talk about the 2 parallel lines L and M running vertically, well, that only includes either 7 or
So creepy.
8. So, yeah.
it's
So,
there.
we can't go diagonally because of that. Does that make sense, Alyssa?
Can we name the ghost?
Probably. Okay.
We should name Bobby.
Betty.
Can we do like, can I use 6 as a vertical angle and then use that linear parallel forward?
Sure. Or you can just do 6 as a linear pair of 4.
Yeah, but like my mind didn't work.
Sure. If you want to go here
The
to here,
question
you
was
can.
really, can we use it like?
Yes. Because that's an angle too. We just haven't named it. I'm not asking you to find it if you could. Hayden.
So then if 1 and 4 are both.
that, but like, no.
If
Hey,
1
guys,
and-
listen up. Listen up. Listen up.
If
yeah.
1 and 4 are both 7. If 1 and 4 are both 75, then could we name the other ones also? Like.
She wants to name more.
Are you saying can we also name all these blanks?
Like.
Yeah, you sure you could name our blanks. Do we have to? No, but we could go through and fill them all out. Okay. How could we know angle 1 is the same as angle 4?
Alternating interior.
Alternate interior. It's also linear pair with 8. Also a linear pair with 2. Okay. It's same side exterior with 3. Okay. There's all sorts of ways we can find these. Okay. There's so many ways you can find all of these. And so it didn't matter whether we started with 7, it didn't matter whether we started with 4, or 6, or 3, or 5. We could start with any of those angles and gotten all of these. Okay? The thing is, you have to be really careful, because what happens if you make one mistake early?
Everything messes up.
You gotta be careful there, okay? Kind of like a Sudoku puzzle. You guys ever done that?
Oh my god, I hate those dumb things.
Oh,
I always get stuck.
sometimes I do them like as like I'm like going to sleep. Like as like like if I'm like I need to turn my mind off because like it's like running a lot, like I'm thinking a lot. I'll just like play Sudoku.
Yeah, you have to use your mind to do Sudoku. Unless you're just like a genius.
Not
then,
when
like,
you're a math teacher. Yes.
I just like
Like
watching.
it legit like calms me down and gets me to stop.
Like,
I'm like, oh, I can just
I
do
can
Sudoku
do
and go
like the
mindless.
6 ones, but I can't do anything above 6.
What?
Do you have life hacks to do those?
That'd be good.
I can get up to 6.
You do
Mr.
it
Johnson
right.
doesn't count sheep. He just does like multiplication factors.
It's a real thing, yeah. Rowan's face just looks genuinely concerned. She's like, this is the new low.
Like Betty.
Okay. Questions on this?
No.
Okay.
Ah,
Googling
I have this thing that's called
Mercy water.
like Belinda, but like.
Alright. Hey, I have this this worksheet for you guys, okay? It's a 4-1 to 4-2 worksheet.
But what if we did?
Mr. Fossil, I have to tell you something really funny, but I can't say it.
If it's not appropriate, then it's not appropriate.
It's not not appropriate, but
I feel like you get to censor yourself in front of class.
it's not okay. Like it's really not.
It's a
If you ask Kevin, like, it wasn't as awful as I made it sound.
Agreed.
Oh.
So guys, the first one has a lot of blank space on it. Actually, I should adjust it. Anyway, yeah, but anyway. Alright. Hey, I want to bring your attention to number 16. Number 16, what do we see there? There's a little asterisk, a little star there, okay? What does that mean earlier in our notes?
2 steps.
Yeah, we had to do 2 steps. What's it going to mean here in our homework?
2 steps.
2 steps. Okay, y'all are wild. Okay? And on 22, it's just a 2-step proof. Okay? So you can go straight there. I know in our notes, we had to circle around because we were proving theorems. On 22, you can go straight from your first to your second step. You can go straight there, okay?
Wow.